The following video is going to be GCSE revision for higher topic trigonometry, mostly focusing on the A and A star questions. Now the difference between trigonometry at grade B and grade A and A star is that at grade A and A star, most of the triangles you'll use will not be right angle triangles. So although we know our SOHCAHTOA and Pythagoras and things, we can't use that when it's not a right angle triangle. However, trigonometry still applies in some different ways, which you're about to see. So, the things you need to know for the grade A and A star trigonometry questions are the sine rule, the cosine rule, and the area of a triangle when your triangle is not a right angle triangle. Now, the good thing for that is that they're actually all given in the formula sheet at the start of your exam. So each of these are written just like that in the formula sheet. The only thing you need to know is how to actually use them. First thing to look at then is this triangle here. As you notice, angle A, angle B, and angle C are all capital letters, and that's always the case in a triangle, even if it's PQR or XYZ. The angles will always be in capitals. The lengths of the sides, therefore, are always going to be small letters. The way you can know which angle and which side it's talking about is that side A, small a, is always opposite angle A, which is capital A. Same for side small b, angle capital B. And in small c, opposite capital C. So if we look at these rules, I'll start off with the area of a triangle rule. The area is half AB sine C. Now that's actually similar to just the normal area of a triangle, a half AB. The only difference is it's got sine C, which is always the angle between it. So one side, small a, another side, small b, and then the angle between them, half AB sine C. The cosine rule then is side A squared equals side B squared plus side C squared, which is actually just like Pythagoras. But then because it's not a right angle triangle, we need to minus 2BC cos A. So if you look through, you've got side, 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 then angle. The important bit about the cosine rule is that whatever side is at the start, that's the angle that you use at the end. So that's very important using the cosine rule. In the sine rule, you've got side A, side B, and side C all in the top, over sine A, sine B, sine C. So A over sine A should be the same as B over sine B, which should be the same as C over sine C. Now mostly when you use the sine rule, you only use two of these things. You won't actually need to compare all three. So let's look a bit more detail then in the area of a triangle. Right, here's a triangle. We've got two sides and the angle between, so we can work out the area. The first thing you need to do, and you can actually get marks for doing this, so it's worthwhile, is just copy the rule out from the start of your exam booklet. Area equals a half AB sine C. The next step then is just to substitute in what you know. Well, we know that A and B are going to be 10 and 7, so it's a half multiplied by 10 multiplied by 7 multiplied by sine of the angle between them, which is 60 degrees. Type that into your calculator, half times 10 times 7 times sine 60, 30.31 centimeters squared. Now mostly they'll ask for these questions, the answers to be given to three significant figures usually, or something like that. So there it is, 30.3 centimeters squared for your area. Okay? Now, a different style of question you might get for area of a triangle is where it gives you the area, it tells you that the area is 40 centimeters squared, and asks you to find a length. So find the length xz, this length here. Now, I'm going to label that length little y, because it's opposite angle y. And then I'm going to try and use, I know I'm working with area, so I'm going to write down my area formula, a half AB sine C. From there, I then fill in what I know. Well, I know that A is going to be 10, B is going to be y, and C is 110 degrees, the angle between them. So 40 equals a half times 10 times y times sine 110. So 40 equals, well, half times 5 times y times sine of 110, which is 0.9397, let's check that. Sine 110, 0.93969, yeah, so 0.9397. And then all we do is rearrange that and solve it to get y equals 8.51 centimeters. to three significant figures. So using the area formula, you can work out the area if you need to, as long as you have two angles and the two sides and the angle between them, or you can use it in reverse to work out what one of the sides were. Okay, the next bit is the sine rule. So the sine rule, like we said earlier, is there. So it's a over sine A equals b over sine b, which equals c over sine c. Now, when you're using the sine rule, you'll be always given three pieces of information, and then you're going to work out what the fourth is. Those pieces will either be two sides, any two sides, and an angle opposite to one of them. Then you're going to work out the other angle, which is opposite to the other one. Or if you're given one side and any two angles. So you'll be given a side and the angle opposite plus another one. You just need to work out then the other side. Two examples of these questions are like so. So on the left hand side here, we have two sides, 9 and 4, and the angle opposite 9, which is 75 degrees. So we're going to be working out the angle R. Find the angle R, and it's opposite to 4 centimeters. So, how do we do that then? Well, we know that it's going to be R, side R over sine R, equals the length P over sine P. Well, we can fill in what we know. 4 over sine R equals 9 over sine 75. From there then, we can work out some values. 4 over sine 9 divided by sine 75. 9 divided by sine 75 equals 9.317. So that's that value. 4 over sine R equals 9.317. With a bit of rearranging, sine R equals 0.4293. Now, because we've got sine R, thinking back to your grade B trigonometry stuff, to work out what R is, we need to do the inverse sine of that. So R is the inverse sine of 0.4293, which works out at 25.4 degrees. So that's angle R, 25.4 degrees. Okay, the second style of question then is one where we're given two angles and one of the opposite sides with it. So this time we've got 4 over sine 40, and I'm going to work this one out as we go. 4 over sine 40, because they're the ones that are opposite each other, equals this length here, which we don't know. It's opposite z, so we'll call it length little z. Z over sine 95. So using that, we should be able to work out what this length is. So we can type that in. Let's go 4 divided by sine 40 equals 6.2229 equals z over sine 95, which is 0.9962. So z should be those two numbers multiplied together times by 6.2229 equals 6.199. So the three significant figures, length z equals 6.20 centimeters. And that's that done. So using your sine rule, sometimes you can work out an angle, other times you can work out a length, as long as you can make the pairs match up with the sides and the opposite angles. And that's it. The cosine rule then. The cosine rule, we use that whenever and two examples again. When you know all three sides and you want to calculate an angle, you can use the cosine rule. Or when you know two of the sides and the angle between them, and you need to work out the third side. So here's two examples. The first example, we've got all three sides and we want to work out angle x. So let's look, what's the cosine rule say? The cosine rule says that a squared plus b squared plus c squared minus 2bc cos a. And remember, the letter at the front, the length at the front corresponds with the angle at the end. Well, since the angle here is going to be a, we're going to use this 4 centimeters as our first value. So the first thing I'm going to do is write out the formula. A squared equals b squared plus c squared minus 2bc cos a. Then I'm going to fill in what I know. So a squared is going to be 4 squared equals 6.9 squared plus 4.2 squared minus 2 times 6.9 times 4.2 times cos x, because that's what the angle's been labelled in here. If I do a bit of calculating, I'm going to get 16 equals 6.9 squared plus 4.2 squared, 65.25 minus 2 times 6.9 times 4.2, 57.96 cos x. So with a bit of rearranging there, cos x is going to be it's going to be 0.8497. So that's cos x. Now, to get x, we're going to have to do the inverse cos of this, 0.8497. So x is a value, inverse cos of, open brackets, 0.8497. It's 31.82 degrees. 31.8 degrees to 3 significant figures. So that's how we can use the cosine rule to solve that. Okay, that was the cosine rule finding out an angle. And again, you had to use inverse cos to do that. You always end up doing that when you're finding an angle. Here's one where we're going to find the side. So we have two sides and the angle between them. We're going to work out the other side. Well, this other side is going to be capital C. Or sorry, not capital C, small c, because it's a length. So small c. So because we've got that angle, the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. However, since this is the angle we've got this time, that's the way we're going to write it. So we're going to start with c squared equals a squared plus b squared minus 2ab cos c. So the angle at the front is always, this length at the front is the angle at the end, with the other values in the middle. Now we're going to substitute what we know. C squared equals 3 squared plus 7 squared minus 2 times 3 times 7 times cos 35. So C squared equals 3 squared plus 7 squared minus 2 times 3 times 7 times cos 35. Which is 23.5956. So C is the square root of that, which is 4.86 centimeters to 3 significant figures again. And that's how the cosine rule can be used in that circumstance. Okay, so that's pretty much everything. The only trickier thing you might have to do is where you need to find the area of a triangle.